Hey everyone, and welcome. We're diving into our planet's ever-changing shorelines. Now, we often think of the sea as this, destructive force, always tearing away at the land. But what if I told you the sea is also a master builder, creating brand new land right before our very eyes? Let's get into it. And that's a great question, isn't it? Because, yeah, the image of a dramatic cliff collapsing, that's what usually sticks in our minds. But the quiet, patient process of land being born, literally one grain of sand at a time, is every bit as powerful. And that's what we're going to explore today.
You see, every single coastline is basically a battleground between two massive forces. On one side, you've got erosion, the destroyer, wearing things down, and on the other, you have its total opposite, deposition, the creator, which actually builds new land. Today, we're all about the creator and its incredible work.
And to really get a handle on how this all works, we're going to follow the adventure of just one single grain of sand. Believe it or not, this tiny traveler is about to show us how entire landscapes get built from the ground up. So this journey, it's not a straight line, not at all. It's much more like a gigantic natural conveyor belt that runs right along the edge of the sea, powered by the waves and constantly shifting material from one place to another. And this conveyor belt has a name, of course, longshore drift. And this is the single most important process we need to understand today. It's the engine that moves all the building blocks, the sand, the pebbles, all of it, along the coast. Okay, so how does it work? It's actually surprisingly simple. A wave, which is driven by the wind, doesn't hit the beach straight on. It hits at an angle. That's called the swash, and it pushes our grain of sand diagonally up the shore. Then what goes up must come down, right? Gravity takes over, and the backwash pulls the water and our grain of sand straight back down. Swash at an angle, backwash straight down, over and over. And that creates this constant zigzag, marching sand steadily down the coastline. And during this longshore drift, it's not a one-size-fits-all kind of trip. Our little grain of sand is probably light enough to just be carried along in the water. That's suspension. But bigger pebbles, they kind of hop and bounce along the seabed in a process called saltation. And the really heavy stuff, that just gets rolled along the bottom. That's traction. It's a whole transportation system, all sorted by size and weight. So, our grain of sand has been zigzagging its way down the coast. But what happens when that coastline suddenly changes shape? Where does all this material actually end up? Well, this is where the real magic happens, and we get to see brand new landforms being born. Let's kick things off with a spit. So picture this. The coastline makes a sharp turn, maybe where a river meets the sea. But that longshore drift conveyor belt, it doesn't turn. It just keeps on going, dumping our grain of sand and billions more just like it out into the open water. You can see the process right here. That sediment just keeps piling up, pushing further and further out to sea, creating this long finger of new land. And sometimes, the end might get a little hook or curve on it if the wind or waves change direction. But the process is the same. Simple, relentless deposition at work. Now, what if that spit just keeps on growing? If it stretches all the way across a bay and connects one side to the other, it's not a spit anymore. It's called a bar. And that calm, sheltered water it traps behind it, that's a lagoon, a completely new and unique habitat, all thanks to our coastal conveyor belt. And check this one out. This one's really cool, a tumbelow. This is what happens when that same process of deposition builds a literal bridge of sand that connects an island back to the mainland. It's a natural causeway, built one grain of sand at a time. Just incredible. So we've seen how water creates these amazing landforms. But these new structures, they don't just sit there. They become the foundation for entire ecosystems. We're going to see how deposition doesn't just build land. It also sets the stage for life to take hold, especially when the wind gets involved. So let's go back to that spit we just built. Think about the water it's sheltering. It becomes incredibly calm, right? And this new protected environment is the perfect place for a very specific and very vital type of habitat to take root. In that super still water, the tiniest, finest particles like mud and silt finally have a chance to settle out and drop to the bottom. Over time, they build up, forming these rich mud flats, and eventually they grow into lush salt marshes. These are incredibly important wetlands, absolutely teeming with life, and they only exist because of the shelter a spit provides. Okay, so that's the story in the sheltered water. But what about out on the main beach where the wind is king? Well, building a sand dune out here is kind of like following a recipe. You need 3 key ingredients. First, a huge supply of fine, dry sand. Second, a strong, steady wind blowing in from the sea. And third, just a little obstacle, anything from a piece of driftwood to a tiny plant to get the piles started.
And dunes, well, they have their own life cycle. They start off as these small, shaky little embryo dunes right at the back of the beach. But as they trap more sand and plants start to grow on them, they evolve into taller, more stable yellow dunes. And eventually, as they get older and move further inland, they become gray dunes, with darker, much richer soil that can support a whole community of different plants.
And here is the absolute key to all of this. The plants are the real architects here. Super hardy plants like marram grass have these incredibly deep root systems that act like a net, holding the sand together and making the dunes stable. Then, as these plants die and break down, they add nutrients, turning sterile sand into actual soil and paving the way for a much more complex ecosystem to develop.
Okay, so we followed our single grain of sand on this massive, incredible journey. What's the big picture here? What's the main thing we should take away from all this? It's this. Our coastlines are alive. They are not fixed, static lines on a map. They are dynamic, living, breathing boundaries that are constantly shifting, growing, and shrinking. They are one of the most active and fast-changing environments on the entire planet, a place where land is both born and broken every single day. And that leaves us with a really urgent question for our time. We've just seen the incredible power of the sea to build new land, but in an era of climate change and rising sea levels, can these natural construction projects actually keep pace? Can our coasts build fast enough to outrace the rising tide? It's something to think about.